Okay, welcome to this lecture. Today I am going to talk about the filtration as one of the water treatment process. Now, the filtration is very important. The filtration has actually reduced lots of diseases in the developed world, and the filtration is therefore an essential process in water purification. I told you earlier, even though we have sedimentation tank, coagulation, flocculation and everything, we were removing only 70% of the solids with sedimentation tank. Now we are left with another 30% of the solids which are smaller in size, and then that smaller in size you cannot wait very long time to settle down in the sedimentation tank. Therefore we are going to filter this one out. What is a filter? Basically, you know about filter, you have heard about filter. Filter is just simply some grains, and then there is a bed, and then there is a grain, and then you send the water through. When you send the water through, the particles trapped here in different places, and then when the water goes out without the particles. So it comes with the particle here, and then they are trapping here somewhere on the filter, and then this comes out. So this is the filter. Traditionally people use what they call a slow sand filter. Slow sand filter. Slow sand filter is a simple filter where what people do is they go to the river or beach, they take the sand from there, and then they dump it onto a tank, and then put the water on top of it. Because of the pressure that is developed from this water height, the water is filtered through slow sand filter, and then the water comes out, and then they put chlorine or something, and then they drink the water. And then this is very effective. It was very effective during early days of the human civilization. Still in some places people use, even in advanced developing country, which I will discuss with you. I think probably I will tell you here that in Denmark they use this slow sand filter principle to treat the water. Very ugly water can be turned into actually very clean water. Only problem, by the name implies here, slow sand filter, it filters the water is trickling through this small sand particles very slowly. Because it takes such a long time, when we want to process water, like for example in Sydney, we are processing about 200,000 cubic meter of water every day. So when we process 200,000 cubic meter of water every day in prospect filtration plant, we cannot actually rely on this slow sand filter. If I want to have slow sand filter, I have to have huge area to send the water through. We will see why we want to think about that one. Anyway, so that slow sand filter is the one that makes the water to go down, trickle down very slowly. Now we don't want that to happen, therefore we have developed what we call a rapid sand filter. This rapid sand filter basically means if I want to make the water to flow faster, what I have to do is I have to make this grain size bigger. If I make the grain size bigger, then I will have the water going through fast. Now when we want to think about the slow sand filter as a filter, then we have to calculate something, but I will explain to you. Before that, they had rapid sand filter, and then after the rapid sand filter they developed even improve this one to improve even faster. It's a very fast filter they have improved recently, and then that basically can treat waters of this kind of nature. In huge amount of water can be processed quickly and efficiently, and then you can get clean water. Now in order to explain what is the filter and how do we separate between slow sand filter and rapid sand filter and very fast filter, then what I wanted to describe you is what we call an approach velocity. Simply, approach velocity means, what I want to talk about approach velocity VA. Approach velocity VA is defined as how much water is flowing through, that is in cubic meter per second or meter per day. How much water is flowing in per square meter of filter. So if you have a filter here, then you have square meter area through this, how many cubic meter of water is going through in a day is called approach velocity. So it's basically, you can say it is in meter per day. If you want to describe in cubic meter per second, you are welcome to do that. Then it will come in meter per second. It can come in meter per second. But usually, because we describe in cubic meter per day how much water is processed per day, and then we describe what is the surface area, here we use the term cubic meter per day per meter square, which is basically, we don't do any unit conversion. We say how much cubic meter is going per day, and then you divide by how much is the surface area. Now in the slow sand filter, we usually can get up to about, slow sand filter, you can get about 2.9 to 8 cubic meter per meter squared per day or meter per day. But when it comes to rapid sand filter, you can go up to about 150 cubic meter per meter squared per day. When it is a very rapid filter, usually you can go up to about even 250 cubic meter per meter squared per day. Now in order to do this one, we use actually approach velocity, and then using this approach velocity you can design a filter unit. For example, let's take a simple example of, I want to design a simple filter, and then how that filter can be designed is, we are going to have 200 cubic meter per meter squared per day, and then I want to design something which treat 0.5 cubic meter per second of water. So my Q is going to be 0.5 cubic meter per second. If I have 0.5 cubic meter per second, we have to do the unit conversion to cubic meter per day, because this is in cubic meter per day. Therefore, I have to convert this one to per second to day. So we go back to our unit conversion, which is 0.5 cubic meter per second times 60 seconds per minute, 60 minutes in 1 hour, 24 hours in 1 day. So when you do that, you will get an answer of, this one will be, how much is that? You'll get 43,000 200 cubic meter per day. Now if you want to make 200 cubic meter per second, then you know the area should be VA should be equal to Q over the surface area. So therefore surface area is equal to Q over VA. Q is 43,200 divided by 200. So that will give you 216 meter square. Usually the filters are designed to get about 100 square meter. So we design to get 100 square meter of filter. I can have 2 filter. If I have 2 filter, then is that sufficient or not sufficient? That is the issue. Now any water treatment plant have to have at least one filter not functioning. In case if one of the filter is not working, or if you want to do some maintenance in one filter, you have to have one filter all the time available for you to do any repair there, still supply the water to the customer. So therefore you cannot have just 2 filters. That 2 filters is not enough. We have to have at least 3 filters. Then you can have 1 filter closed and then 2 filter working at any time. But in water treatment plant again, they don't have 3 filter, they usually have 4 filters. Okay, so the reason is because again this is the principle of having 2 filter paper or 2 filter 2 system, like you can close one part and then you can operate the other part. So you don't have a single filter, you have double filter. So therefore it's going to be 4 filters, and of course each of them is going to be 100 square meter, or you can have 80 square meter each of them. Then you can operate 3 filters at a time. That will give you 3 times 80, give you about 240 square meter. Then the rest you can keep for future use. So that is how this one works. So I hope you understand what I was talking to you. So basically what I wanted to tell you is there is a slow sand filter, a rapid sand filter, and very fast filter. Now in this particular video I tried to cover very basic of water filtration process, and I will talk about these things in very much detail when we come to the class, and then I will do some more examples too. Thank you.